Hello, and welcome to Aggressive Physics. Today is day 11, and we're going to start to do some practice problems for the next few days in order to better our problem-solving skills. Each day I'll focus on a different type of problem involving uniform acceleration and freefall, and we'll see if we can solve these problems together so that when you are trying to solve problems at home, during classwork, during homework assignments, tests, or quizzes, that you can approach them in a similar way and solve them on your own. For day 11, I'd like to look at problems where we drop objects from different heights. And we're going to find information about final velocity, perhaps the time it takes to land, the displacement that the ball will move, and other types of variables such as that. So today, for day 11, we're going to stick to just problems dealing with dropped objects. Dropped. So for the first one, a baseball is going to be dropped from the top of a two-story building . Very important that it has two windows and a door. And obviously not to scale. That's a pretty big baseball otherwise. And the height is 20 feet. Uh-oh. I see a problem already. How long will it take to hit the ground? How fast will it be moving? Well, the first problem we have here is that we need to get rid of that feet, or convert it from 20 feet into meters. We need metric system here. 1 meter is 3.25 feet. The feet will cancel, and we'll be left with meters. So 20 divided by 3.25 yields 6.1538. So I'm going to go with 6.154 meters. A little extra precision on this problem. Now, that being said, what I want to look at is all the givens I have. And the givens I have are going to be the displacement, which is negative 6.154 meters, dropped, hidden variable, VI is 0. The acceleration, since it's near the Earth's surface, negative 9.8 meters per second squared. And we want to find how long it will take, t, and how fast we'll be moving, Bf. So, looking at the variables that we have, I'm thinking equation 4 would be appropriate. D equals VIT plus 1/2 AT squared to solve for t. D, negative 6.154 meters. VI, 0 times t, plus 1/2 negative 9.8 meters per second squared, t squared. Okay, this term cancels. We have negative 6.154 equals negative 4.9 t squared, and we could solve for t. 6.15, I have the number still in my calculator, so I'm going to divide that by 4.9 since the negative signs will cancel. I have 1.255, which will be a choice because I forgot to take the square root, and I'll get 1.12 for my t when I do the square root. Now let's say I did that wrong and I tried to solve for VF with that incorrect t. Well, I'd only lose credit for the t. If I use the wrong information to solve for the next part, we don't have double jeopardy, and you end up only losing points for the one mistake you made. And that's assuming we get the second part right. If you were to use t, I would probably use equation 3, but since we're looking for VF, I'm going to use equation 5, 2AD. So, VF equals, minus 0 squared to negative 9.8 times negative 6.154 meters. All right, I'm going to multiply 2 times 9.8 times 6.154, and then I'm going to take the square root. And I'm going to get 10.98. VF equals 10.98 meters per second. Now, there is one problem when we take the square root of a number, and that is we have to choose which root to use. If you remember, the square root gives you plus and minus the 10.98. So we have two answers every time we take a square root. In this case, we want to use the negative because we know the object is moving downward. It's about to hit the ground. It's moving in a negative direction. So our final answer is negative 10.98 meters per second. All right. The next problem involves a sack of rice falling off a table. We have a sack of rice, and it's going to fall off the table. The table happens to have a height of 0.85 meters. The sack of rice is knocked off of the kitchen table, which is 85 centimeters high. So I've converted that directly. Remember, centimeters to meters is 2 decimal places. How fast will the sack be moving 0.25 seconds after it starts to fall? Which is going to give us a value somewhere around here. I'm not really sure exactly how far it's fallen, but it's fallen for 0.25 seconds. Now this problem would normally start with the 0.85 as your displacement. Since it's knocked off the table, you have to assume that VI is 0 on its way down. Maybe it's pushed off the edge and it starts to fall. And what we're going to do is not use that 85 centimeters. In fact, VI is 0, T is 0.25 seconds, acceleration is negative 9.8 meters per second squared, and we don't actually know D. But a lot of people are going to want to put negative 0.85 meters. So right here we have an extra variable that's not needed for the problem. And sometimes problems will have extra information that you don't need to solve a particular part. Some problems have multiple steps, so you're looking for solving many different variables, and in this case the 0.85 is extraneous. Now what we're trying to find is how fast, so VF. And if we look at this, it boils down to a strict VF equals VI plus AT. VFs are unknown. VI is 0, negative 9.8 meters per second squared, times 0.25 seconds. So all you have to do is do 9.8 times 0.25, and you get VF to be negative 2.45 meters per second. So watch out for problems that have extra information. In this case, the height of the table was extraneous.